Yeah, you are right.
Hello, very good evening, everyone. So this is a nice. You might get a surprise that I'm also here in today's workshop. So we have Apar with us, who is also joining Google uh, tomorrow only, and he is also a mentor with Coding Minutes. How many of you already know about Coding Minutes? Okay, uh, many students are on Google Meet. Why on Google Meet? So he would be teaching you today on 2D grid problem solving. And in the meanwhile, if you have any questions before we begin, feel free to ask to me, both Apar and me. Then, yeah, okay, no questions. Okay, we are ready to go. So a little bit more about Apar. You can tell the students about your how you improved on code forces, how you became a expert, I think
Master.
master on code forces and 6 star on code chef. So he's a great competitive programmer. I admire him a lot. That's why I asked him to come and also create some pocket friendly courses on coding minutes. Okay. Hi Rahul, hi everyone. So many of you already know about us, and Apar also launched one course with me last week on Udemy. Okay, so how many of you know about this graph algorithm specialization? So we will take just one more minute, and then we will dive into today's topic. Okay, so I will just quickly tell you about what we are trying to do. So we are trying to bring some amazing courses from which you can learn, you can ask doubts, and these courses are hosted on Udemy's platform. We are not building our own platform, but to get information about these courses, you can definitely visit this website. You can visit this website for an online ID. So Apparent we created this graph algorithms specialization on Udemy, and I feel it is the most exhaustive course on the entire planet that covers graphs in so much detail. So yes, Zaved, yeah, he was also guiding a lot of students. Okay, so now I have some questions that is CP necessary. So it can be answered in either way. Okay, so if you're getting joy out of it, definitely do it, but to a certain extent, to get the knowledge, if you want to be a software developer, you should have certain knowledge of data structures and algorithms. Okay, so CP also covers a lot of advanced topics which may not be asked in interviews, which may not be useful in that much useful in your regular life, but in general you should have good problem solving abilities. Competitive programming is necessary for everyone. That is something I would not say. Even I have not done a lot of competitive programming. Okay, yes. Okay, will there be a course on DP? Do you want a course on DP? So if yes, we can definitely make one course on DP. Okay, so what are the plans of coding minutes for the upcoming month? We For July, so we are planning to bring 3 courses in July: Git and GitHub master course, data structures algorithms, which is taught by me, and a complete Python 3 master course on Python, Pygame, projects, object oriented programming. And the next month, that is August, we are bringing the competitive programming course. Okay, so online coding rounds, they do have competitive programming questions, but I feel they are not that hard like you get in mostly in like long challenge or something like that. Those are problems which require quick thinking. Okay, and they can be solved using data structures which are available in the libraries. Okay, so the only thing is you have to find a pattern in the problem, apply a relevant data structure and solve it. Okay, all right, thank you everyone. So I will hand it over to Apar for further session. And Apar, you can add your screen and start with the topic. Okay,
Okay.
so
Hello,
okay,
everyone.
you can start with one note. Okay.
Cool.
Hmm.
So, hello, everyone. This is Apar, and uh, so I'll be starting with Google tomorrow. Of course, it's a big day tomorrow. And before that, let me introduce myself to you. I have already worked with Zomato and Samsung, and I have been with great education startups. So again, Coding Minutes is another pocket-friendly startup for all of you, right? So as Pradeep has already described about Coding Minutes, so I'll move on to the problems that we'll discuss today, right? So today's workshop is about, okay, so I'll take all the doubts later words, like doubts regarding CP and other things, right? And yeah, so as already discussed, that online rounds, that are the interview rounds, the interview preparation rounds for big companies, big tech companies, all of them have some coding interviews, right? But before that, they have online coding rounds. So online coding rounds are like 70% similar to competitive programming rounds, or less, or more. I think it is 80% similar to the competitive programming rounds, right? Where you get some bunch of questions, easy, medium, and hard, and you have to solve them under a given time constraint, right? So basically, the main purpose of competitive programming is to make you excel in like data structures and algorithms at a competitive level, where many of us are competitive, like trying to compete on the same platform and trying to have some ratings and rank, right? So it's basically a sports where you practice and then you participate in contest, right? So that's what happens in sports. You practice a lot and then you check out your skills by participating in great competitions. So it's similar to that, right? So let's begin on with today's workshop, and the workshop is about 2D grid problems, which are actually solvable using graph algorithms. So in all of these problems, we'll be given a 2D grid, of course. Initially, it will be a 2D grid and some constraints and other things. But after that, we'll like notice one of the things, that all of them are actually solvable using graph algorithms only. The 2D grid will itself convert to a graph, right? So let's begin with the first problem. And yeah, so I have four selected problems for you all, and all of these four are interview problems. And like, firstly, I have an easy problem, then medium, then we can say an intermediate problem, and then a hard problem, right? So I'll cover all of these problems. All of them were asked in very big tech interviews, right? So let me check some. Okay, so it is great. So we'll try and make a DP course, but right now we are planning like 2 months after today. Basically, we are planning a good CP, competitive programming course, which will cover essentials, right? That the algorithms and data structures that you must know for competitive programming, so that you don't waste your time here and there by like learning data structures algorithm from the problems only. First of all, you will just gather all the knowledge from that course, and then you can apply it on the contest and solve problems, right? Cool. So no more comments, and let's begin with this. So basically, the first problem is very very easy. It might not entertain the medium level students here, which is given a grid of size n cross m, color all its connected component and print their sizes. Right. So there's a lot of gray area in this connected components part. Right. So first of all, let me make a grid. Yep. So here we can see the grid has four columns. That is, m is equal to 4, and n is also equal to 4, like symmetry, right? So n is equal to 4 and m is equal to 4. It is, oh sorry, n is equal to 5, right? So it is a 5 cross 4 grid where we have 5 rows and 4 columns. And what I'll do here is I'll make it a binary grid, right? So let's make it a binary grid. What is a binary grid, guys? Binary grid is a grid which contains only zeros and ones, right? So wherever it's mentioned that you have been given an n cross m binary grid, just consider that the grid will only contains 0 and 1s, right? So let me write some zeros and ones, right? So yeah, n is equal to 5, Gaurav, no problem. So right now we have an n cross m grid, and what we have to do is we have to color. Color means that we have to give some color, that is 1 2 3 4, any color we can give to all its connected components. So every connected component will have a color of its own. So now let us define that what is a connected component, right? So what is a connected component, guys? So what we'll do is we'll define connectivity between two cells first, right? So this connectivity will remain for all the other problems that I'll discuss, right? So what is the connectivity between two cells? So if two cells share a border, what is a border, guys? If I have this cell, so this cell has four borders, right? The first border is the left one, the upper one, the right one, and the down one. So it has four borders, right? So if any two cells share a border among themselves, that means they are connected, right? So what does this mean, guys? That if I'm on a cell x comma y, let's make a cell x comma y, then it is connected to four cells, right? The above cell. So guys, speaking very frankly, firstly I've just picked up a very easy problem for all those who are very new to programming, right? I'll try and explain this problem in detail, in deep, of course. But after this I have some very good problems, like medium level problems and also hard problems, right? And all of those problems will be converted to a graph problem later. So I would just suggest you hold put and we should continue on this function, right? Right. So we have got some solutions here. Akash says that it can be solved using BFS and DFS by keeping account, right, Akash? So that's what I said. That the first problem is for beginners, right? So it's very easy problem. It's like the very basic problem of 2D grid and graphs, right? So just stay put, and we'll I will get on to some problems which might be challenging to you, Akash, right? Cool. So if I have a cell x comma y, then the cell which is above it, what is the cell above it? It is equal to x minus 1 comma y, right? Why x minus 1? Because one row above. The cell below it, which is x plus 1 y. The cell right to it, which is x comma y plus 1, because the column has been increased. And the cell which is left to it, which is x comma y minus 1. So all these cells will are connected to the cell x comma y, right? So this is what is a connectivity in my problems, that if two cells share any borders, any sides, then they are connected, right? But there's one thing to notice, guys. Let's say if x comma y is equal to 1 comma 1, then 0 comma 1 is on the okay, so 0 comma 1 is above 1 comma 1, right? But 0 comma 1 is out of my grids. That means 0 comma 1 is not a cell. Why? Because right now I'm considering one base indexing, right? So if I mark their indexes, then it is 1 2 3 4 5 and 1 2 3 4, right? So this cell, the top left cell, is equal to 1 comma 1 cell, right? So we all know how to index the grid. We all have gone through this JE preparation, right? So this is the introduction of the problem, guys. A very easy problem, and of course, guys, we'll code all the problems here, right? And it will be a very good workshop, very informative to you all, and you will see some new coding styles, right? That will help you save time. Cool. So let me check on some comments. So I'm taking 5 problems. Great. Okay, so fine. So now what we have to do is we can see that here we have some connected components of ones, right? And also we can say that we have some connected components of zero, right? So what are the connected components of one, guys? This is a connected component of one. Let me color it blue. So this cell goes with this cell again. It is connected to one, and this is the second connected component. Let me color it red. Second connected component, and then we have a third connected component. Let me take some other color, purple, right? So this is the third connected component, guys, right? So in this given grid we have three connected components. Now how is this grid being converted to a graph, how is this question related to a graph? Because we have defined a connectivity, right? It all depends on the connectivity, guys. See, there are different types of connectivities, right? The second connectivity can be, even if the cell shares a border, that means not a border, mean a corner, then also they are connected. Let us say that if two cells share even a corner, then also they are connected. That means these cells that are on the corner of the x comma y cell, then all these cells would have been also connected, right? So if we have defined a connectivity of these cells, then what we'll do is we will simply make a graph of this grid, right? The graph is simple, that uh, so right now what I'll do is I'll make 5 nodes, and then we'll make 4 other nodes, right? That means it is a 5 cross 4 grid, but right now it's not a grid, it is a graph. I am connecting this graph, so let's connect it. So we all know how does this connection work. All the cells which are left right to each of them, they are connected, right? Let me, so these red are edges between the vertices of my graph, right? So I'm connecting this, I'm converting this particular grid to a graph, right? So if I consist all of the cells to be vertices of my graph, and all the adjacent cells, they are connected by edges, right? So this grid finally converts to a easy graph, right? And what are let me write their values here. So it is 0. Okay, let me write in white. 0, 1, 1, 1, 1, right? 0, 0, 0, 1. We have 0 zeros here, another 0 over here, 0, 0. So this is 1, this is 0, 0, and yeah, cool. So one more 0 on the bottom right. So let me check some comments, right? So guys, we have converted. So we are actually in code, we won't actually convert the grid to a graph, right? We'll simply apply breadth first search in the grid itself, right? We'll be doing a breadth first search here. But right now, let us understand what does these ones and zeros means, right? So right now, what I want to do is I want to find a connected component which consists of ones, right? So if I try and start a breadth first search from this particular cell, that is the 1 comma 1 cell, this is 1 comma 1 cell, right? This is our vertices with let's name them as the index of the matrix only. So it is a 1 comma 1 cell, and can I start a breadth first search from this particular cell? No, I cannot start a breadth first search from this particular cell. Why? Because it is already a block cell, it contains a 0, right? So I'll try and start a breadth first search from a cell which consists 1, right? So if I start a breadth first search from this particular cell, guys, let me purple it, this cell, right? So if I start a breadth first search from this cell, so the cell on the left of it won't be pushed into the queue because BFS works on the queue basis. The cell on the right of it won't be pushed into the queue. Why? Because that's a block cell, both left and right are the block cell. So the cell which is down to this one will be pushed into my queue. Why? Because it is connected to the upper cell, and it has 1. Now the breadth first search will move on. Now this cell will be pushed into my queue, this cell will be pushed into my queue, right? So after one particular breadth first search finishes, right, then we get a one connected component, right? That means all the adjacent nodes of one are visited, right? So guys, we can either do it using a breadth first search, or we can do it using a depth first search, right? So generally depth first search is easier to code, and breadth first search is harder to code, right? So we will well, it's a very easy problem. You can try code it yourself, right? So I won't be coding this, it's a very easy problem. Try if you are a beginner in this particular field, then you can simply like try coding it out yourself, right? A DFS and a BFS, try coding it using both of these, and color these components and print their sizes. It's very easy, right? The main motive to take this question was that any grid can be converted to a graph with some edges in them, right? Cool. So let's move on to the next problem. Right. So let's discuss the time complexity of this particular problem. So what will be the time complexity here of a normal DFS or a BFS if I don't visit any node twice? It will be O of NM. Right. Why? Because nm is equal to total number of vertices in my graph, right? And I'm visiting every vertex twice, every vertex once only, right? Why? Because whenever I'm visited it, whenever I'm going to any vertex, I'm marking it as visited and I'm moving on, right? So what is the total time complexity? What will be the total time complexity if you use a bfs or a dfs? It will be o of nm, right? Why? Nm is equal to total number of vertices there, right? So let's move on to an interesting problem. Let's move on to the next problem. So I hope you have understood how can grid problems be converted to graph problems. So the key guys here is that generally whenever you see a grid problem, it involves finding a minimum value path from 1 comma 1 to n comma m, but it's about the directions, right? So if it says that the directions are only right and down, that means from a particular cell you can only go on the right of it, or you can go on the down of it, right? So if you can only go on the right side of it or the downside of it, then it generally becomes a dynamic programming problem, right? Because here the paths are one directional, right? That means if from a node x comma y I go to some other node called a comma b, then I cannot come back from a comma b to x comma y, right? Those are directed paths, right? But as seen in this problem, the connectivity is defined as we can go in all the directions. We can move up, we can go left, we can go down, we can go right. So if I can go in all directions, then it doesn't become a dynamic programming problem. Why? Because if I apply dp in this, then a particular state is dependent on the other state, and that state is dependent on this state too, right? Because I can go in both the directions, right? So it will become an infinite loop because both the states are dependent on each other. So that's why these types of problem in which you can go in any direction, they become graph algorithm problems, right? So in the starting also, it was kind of confusing to me that okay, I've done lots of problem which are going right, which are going down, right? They are going in one direction, so I directly apply dp to them. But then when I saw these types of problem that I can go in any direction, and then there was some sort of uh, statements, right? Then I got a little confused, right? That how will I solve these types of problem which I can go in all four directions? So always remember, every grid problem can be converted to a graph problem, and graph algorithms can be applied on them, right? Cool. So let's move on to the next problem, and it is pretty nice problem. So we have been given a grid of size n cross m. All cells have values written on them, right? So all the cells have values written on this particular grid. You can only move to a cell which has lesser value than the current cell. Tell whether a path exists from 1 comma 1 to n comma m or not, right? So first of all, let's make a grid. Let's make a very short grid. So guys, a problem statement must be clear to you. If not, please comment it out if it is not clear. I'll explain it again. We have been given a grid of size n cross m. So n is 4 here, and let's take m is equal to 3. Cool. So n is 4, m is 3, and we have some values written on each of these cells. So let me write some values here. Let's take values 4, 3, 5, 2, 2. Let's take 4 here again. Let's take 9, or it would be better if I take 2 here. Let's take 1. Let's take 4, 2, 3, 1. Right? Okay, once more. I got a comment saying once more. Great. So the problem is very simple, that you have been given a grid of size n cross m, and all cells have values written on them. So I have written the values on each of these cells, guys. You can easily see 4, 2, 1, 3, 5, 2. And you can only move to a cell which has a lesser value than the current cell. That means now I can see, I can go in all the four directions, right? I can go up. So as I already said, the connectivity of all the problems are same. I can go up, I can go left, I can go right, I can go down, right? That means I can move from a cell to another cell which shares a border or a side, right? But there's additional constraint over here that you can only move to a cell which has a lesser value than the current cell. That means uh, from 4 I can go to 2, from 4 I can go to 3, but from 2 I cannot go to 5. From 5 I can go to 2, but from this 2 I cannot go to 4, I cannot go to 4, and I can also not go to 5. Right? So is the problem statement clear, guys? I'm continuously monitoring the chat, the live chat. If it is not, please let me know. Right? So what are the directions in which I can go? I can go in all the four directions, but the value should be lesser, right? The next value should be lesser. That means I am actually trying to find a decreasing path from 1 comma 1 to n comma m. That whether a decreasing path exists from 1 comma 1 to n comma m or not, right? So cool. So let's find out whether a decreasing path exists in this particular algorithm, right? In this particular grid, right? So from 4, guys, I can go to 2. That means let me make another cell. And so it's a easy medium problem, right? It's not that hard problem, but it's a easy medium problem. But it's a very important problem, guys. It was asked in a very cool company, right, to one of my friends. So guys, here we have this from, so I'll start from 4 and I'll push it into my queue. I'm trying to apply a breadth first search here, right? And now what we do is we try to convert this grid problem to a graph problem. Why? Because we have some certain directions here, right? So how does it become a graph problem, guys? Simple. What we do is we make these cells as a graph, right? So we have so I have made all these cells as a graph here, and let's make connections between them, right? So the connections here are one directional. Why? Because if I can go from x to y, that means y is greater than x. So I cannot go from y to x, right? Because sorry, y is less than x, right? As already discussed, that they should have a lesser value than the current cell. So if I can go from x to y, that means y is less than x. So from y I cannot go to x. Why? Because now x is greater than y. So the paths here are one directional, right? So let me make some of the connections here, some of edges. So from 4 I can go to 2. Let me write these values also so that it becomes easier to understand. No, recursion and backtracking would not work good here, Dhruvil, right? Why? Because if I try and go a if I try and go find a recursive path, do a little bit of backtracking, that will not help us. Why? Because that will take a lot of time complexity, right? We all know that backtracking has exponential time complexities, right? But if you mean from recursion and backtracking, if you mean DFS, then of course that will work here if I don't visit any cell twice, right? So that's the difference between DFS and back. There's a difference between depth first search and backtracking, right? I hope that's very clear for all of you. See, let me tell you a very nice problem. Try solving a sudoku solver, right? So we have a sudoku and we want to solve it. I want to write the code of it. That is a backtracking problem. What does a backtrack mean? That if I have placed some particular value at this particular position and the answer doesn't, that means in the path which I'm going, it's not the correct path. That means by placing this value at a particular location doesn't give me a good path, then change the value and place another value. That's where I'm backtracking, right? That means I'm tracking back, I'm changing the values and finding another path. But that is not how DFS works, right? DFS doesn't change values, right? It just goes and visits every cell until it is not visited. So there's a difference between recursion and backtracking and DFS. DFS is recursion, but DFS is not backtracking, right? Great. So yeah, so it's an easy medium problem, guys. All of you must have some solutions for this. So let me make some edges. I'm just trying to relate it to a graph problem. So from 4 I can go to 3. From 3 I can go to 2. From 2 I can go to 1. From this 1 I cannot go anywhere. From this 2 I cannot go anywhere. But from 5 I can go to 2. From 4 I can go to 2. From this 4 I can go to 2. From 5 I can go to this 2. And so guys, here you can easily see that if adjacent cells do not have the same value, there will be an edge. Either it will be right side or left side or up or down. There will be an edge if they are not the similar values. right? So from 5 I can go to 3, from 5 I can go to 1. So what's the special thing about this 5, guys? The special thing about this 5 is that from 5 I can go to 2, I can go to 3, 1 and another 2, right? But I cannot come to this 5, right? And from okay, so let me make some other edges. From 4 I can go to 1, 4 to 2, 3 to 1, 3 to 1, 4 to 1. So 2 to 2 there should be no edge, and then 3 to 2. Okay, so I have some comments here, that is 5 can go through 3 and 1. Yes, 5 can go to 3, 5 can go to 1, but there is no incoming edge on 5. So I cannot come on 5. So it's useless, right? If I cannot come to any node, it's useless for me, right? 4 can go through 1, 4 can go to 1, right? So as I said, guys, if I have some two adjacent similar same nodes, then there is no edge between them. Otherwise there will be a edge from a higher version to a lower version, right? So guys, now it has become a graph problem, that you have been given a graph. So guys, this is a graph, very easy, right? And how many vertices we have in this graph? 4 cross 3, that means 12 vertices. So we have 12 vertices in this graph, and we have been given some edges which are directed edges. So this is a directed graph, right? And I just want to find whether a path from 1 comma 1 exists which go to n comma m. So what I'll do is I'll start one breadth first search or a depth first search from 1 comma 1. I'll try and go on to this particular graph, that graph I made over here, which have directed edges, right? So I'll perform a DFS, I'll perform a BFS, whatever suits me, go to all these edges, and if I'm able to visit the last cell, which is n comma m cell, that means if I'm able to visit this cell in one BFS which started from 1 comma 1 cell, that means there was a path, because I have made directed edges over here, right? So according to this particular example, I think there is no path, right? Why? Because from 4 I go to 3, from 3 I go to 2, and from 2 I go to 1. From 1 I cannot go anywhere, there is no directed edges from 1, right? So I will not be able to visit the last cell. But if I change some values, let's change some values, guys. So we will be needing some bigger values here. So let's say 9, 8, let's say 1, let's call it 2, and so I'm just trying to make a path here, right? So 6, and let's say it is 2, it is 1, let's say it is 10, and this is zeros. Cool. So now we can easily see that we have a path. How? 9 to 8, 8 to 6, 6 to 10, 10 to 1, and sorry, not 6 to 10, 6 to 2, right? 6 to 2, from 2 I can go to 1, and from 1 I can go to 0. So we have a decreasing path here, right? So as I said, this path only has right and down movements, right? This path only consists of right and down directions, but we can make some other paths too. Let me give you an example of those two. So let's say the values are 5, 4, 3, 2, and 0. So again, we have a different path, guys. That means there can be this path 9, 8, 4, 3, 2, and 0. There can be another path which is 9, 8, 6, 5, 4, 3, 2, and 0, right? uh yes, Gurmeet, this video is available on this link only. It will be forever here, right? So you can check it anytime. And yeah, so what are yeah so I hope you have understood this problem, guys. Now, guys, let's change the problem statement a little. That what if I want to find the shortest path from 1 comma 1 to n comma m, which is a decreasing path, right? So what I have done is I've made slight changes here. What are the changes? That I want to find the shortest path from 1 comma 1 to n comma m, which is a decreasing path, right? So how will I do that? So the major thing here is shortest. This is important. uh any solutions, guys? If I want to find the shortest path, so we all know that if we want to find a shortest path in a unweighted graph, whether it be directed or undirected, what we do is we apply a breadth first search, right? So to find the shortest path in a breadth, to find the shortest path in unweighted graphs, we apply breadth first search, right? So that's what we'll do. We'll simply apply a breadth first search and we'll start storing distances from the source node, right? And what happens so what happens if we just give me a second, guys. Right. So where were we? Yeah. So we were that whenever we want to find a shortest path, like they slightly change. So that's what these companies do, right? They give you a easy problem just to check whether you are able to, whether you have like enough knowledge for that easy problem, and then they give you a follow up question, right? That okay, what if I change the constraint from this to this? Let's say if they change a constraint or they add another condition to it, right? So that's what I'm doing is I'm trying to add another condition. I want to find out what is the shortest decreasing path from 1 comma 1 to n comma m. So it's very easy. We'll apply a breadth first search. We'll start storing the distances. uh, Same as the breadth first search goes on, we'll start storing those distances, and yeah, we'll finally have the answer which is equal to the distance of the n comma m node after the BFS ends, right? So if the distance is equal to, so initially what we'll do is we'll mark the distance is equal to -1. So if the distance is equal to -1, guys, that means there doesn't exist a path. Otherwise, there will exist a path, and we would have found out the shortest distance, right? So let's code it once. Let's try and code it out. Cool. So guys, this is Sublime text, and what I'll do is I'll code here on the left side here in this new.cpp, and on the right side where I have this input and output, let me check some comments. Uh, yeah, Kulbir. So if you do not know what is a DFS, what is a BFS, like breakfast search and depth first search, then these are the first steps of graph algorithms. All the graph algorithms are based on depth first search and breadth first search only, right? So you need to understand these first. Cool. So for DFS and BFS, I can like keep another workshop, or what you can do is you can like check out some content online. You can check out a course on graph algorithm which is on Udemy, right? It's a very pocket friendly course. It will hardly cost you three or 400, and where you can like learn all the graph algorithms in detail, including DFS and BFS. Cool. So this is Sublime Text, guys, and here we'll code everything out, right? So we'll give this input as a grid. Firstly, we'll give n and m, that is 4 and 3, right? Which is n and m. So let me take n and m in the input, guys. Now what I need to do is I need to take grid as an input, right? So let me take this grid as an input, and let me also input the grid, right? So I've taken in a 2D array which is n comma m, which is a grid, a 2D grid. And let's take all these values. What are the values? 9, 1, 4, 8, 4, 3. Next is 6, 5, 2. The other is 10, 1, and 0. right? So 10, 1, and 0. So these are the values of the given grid, right? And let's print all these values first, because I don't want you to get confused. Like, how does Sublime Text work, right? So whenever I'm doing a cin, like I'm taking standard input, that is stdin, that is being read from input.txt file, which is being written out to std out, which is output.txt file, right? W means write to output.txt, standard output, which is cout. Cool. So whenever I'm performing a cout operation, it is being written to this output.txt. I hope this is clear to everyone. What is standard input and output, right? So, guys, these are some small tricks which help us save time, right? How will these help us save time? See, it's very easy, right? I don't have to like switch to another window to like paste some input. Like, I don't have to open the terminal or the command prompt to run this particular executable file and find out inputs and outputs, right? So that's where you can take help of already built functions, which are FRE open in C++, right? FRE open means it will open your file, right? Cool. So now what we'll do is we'll try and apply a breadth first search here, right? And how will I apply a breadth first search? See, guys, I won't be converting this grid to a graph. That means I won't be making a graph data structure again, right? I will only apply a breadth first search in this grid itself. So let's apply a breadth first search in the grid itself, right? So let's take Q, and in the Q I need to take a pair, right? Why pair? Because this is a grid. All its cells are x comma y type, right? So let's take a grid. Okay, let's take a grid which is visited, which will tell whether a particular cell is visited or not, right? So right now I'm considering A as zero based indexing. So let's take visited to be n comma m size only, right? So what I'll do is I'll simply mark all the nodes as unvisited initially, right? So let me increase the size if it is not clear. I hope the size is clear now, right? Okay. So what I'm doing is I will initially mark all the nodes as not visited. That's how we apply a breadth first search, right? And this is a visited cell. This is a queue which will contain all my cells, the BFS queue. So BFS queue, right? Yeah, Rahul, we can do that way too, but all compilers does not support this, right? So I'm like going for a perfect way here. Cool. So after this, what we want is we can also apply this BFS making a visited array, guys. We don't need a visited array. What we'll do is we'll simply take a distance array, right? Initially, we'll fill the distance equal to -1, right? That all the distance of all the cells is -1. So if the distance is equal to -1, that means it is not visited. And if the distance is not equal to -1, that is either it is 0, 1, 2, 3, 4, any positive integer, then we can say it is visited, right? So instead of taking two arrays like distance separated and visited separated, we can use visited array only to find out the distance, right? So let me take one array only, which is distance, and instead of 0, let's put -1 over here. So I hope you got why am I trying to do this, and if you want me to repeat, let me know. Cool. So why am I doing this? If the distance is equal to -1 for any cell, it is not visited. Otherwise, the cell is visited if the distance is greater than -1. Cool. So initially what I'll do is I'll say distance of 0, 0 is equal to 0 from itself. That is the source node, right? And in the queue, I will push 0, comma 0, which is a starting cell, the source cell, right? So yeah, no issues over here. Now what we'll do is we'll apply a while loop until queue is not empty. That is how we apply a BFS. See, guys, I'm going in detail of the BFS. I want you all to understand this, right? So what is X? X is equals to Q dot front, the element in the front, and its first node, right? So Q dot front means the frontmost pair of the queue, which is the node, and first, right? And what is a Y? Y for the current cell, it will be Q dot front dot second, Cool. So this is x and y, and after we get x and y, what we'll do is I'll simply push. Sorry, I'll simply pop x and y from the queue. I'll simply remove the first element. That is the regular working of BFS. Now what I'll do is I'll try to go for all the adjacent nodes of the current node, which is the current node x comma y. Right. So let me write it here. X comma y is the current node, right? So right now I'm considering some easy medium level for you guys, and I'm trying to code it that way, because in the next question I'll be like skipping the details. Cool. That will be a little hard problem. So x comma y is the current node, right? So what I need to do is I need to go for all the adjacent nodes of the current node, right? So what are at the adjacent nodes for x comma y? It is, for x comma y it is x minus 1 y, x plus 1 y, x comma y minus 1, and x comma y plus 1, right? So for that, how can we go for all the four different nodes? So again, there's a very similar trick, guys. That is dx, right? What we do is I take a changes in the x direction, right? So what are the changes in the x direction? 2 times it's 0, 1 it is 1, and 1 it is minus 1. Similarly, guys, what are the changes in the y direction? It is 1, minus 1, 0, and 0. So let me explain you this, because yeah. So let me explain you this, guys. What does this dx dy means? Yeah. Right. So what does this dy, dx and dy means, guys? That what are the changes in the x direction for a particular node, right? Okay. So we have a student here who is not familiar with for and while. Kulbir, again I'll repeat the same thing. If you're not familiar with the basics of any language like for loops and while loops, then then what you can do is you can just try and understand the logical part what I'm trying to explain here, right? Like you might not be getting the code part which I'm trying to code here, right? So just understand the logical part, and whenever you learn how to code, you can apply all of this to the code, right? Or you can check out our courses for the basics of C++ too. Pratik has made an awesome course called DSL Level Up course, right? So you can head on to codingminutes.com, and check out the courses, right? If you're not familiar with the basics of C++. Cool. So let me explain you this, guys. So let's pick up the first column of both these arrays, right? So what I say is I say x is equals to, let's say new x, or let's say double x. Double x is equal to x plus dx 0, and double y is equal to y plus dy 0. So what is this equal to, guys? What is double x equal to? It is equal to x plus, sorry, double x is equals to x plus 0, and double y is equal to y plus 1, right? Now guys, let's take the second example, that is 0 and minus 1. So what we'll get here, x plus 0, y minus 1. The third one will be x minus 1, y plus 0, and the fourth one will be x plus 1 and y, right? So here you can see, guys, we have got all four adjacent nodes of the current node. So if I'm on some node x comma y, then we have x y plus 1, that is x comma y plus 1. The second is x comma y minus 1. Third is x minus 1 comma y, and the fourth one is x plus 1 comma y, right? So that's the use of this dx and dy's. We are actually finding the dx, the difference in x, to the adjacent nodes. Cool. So what I'll do here is double x comma double y, and we'll try and apply this in a double for loop, right? So sorry, in a for loop. So I will go from 0 to 4, and here I'll say double x is equal to x plus dxi. I'm just trying to tell you some shorter ways to apply BFS and DFS. See, the code is very small, right? And you can easily learn this stuff. It's not a big deal. So what I have is dyi. Okay, so how are we going to keep tracking of cells having lesser value than the current, right, path? So what I'll do is whenever I push another node into a queue, another node into a BFS, right? When I'll push it another node into the back of the BFS, at that particular time, I will try and like store at that particular time. I will check that the node which I'm pushing into the queue, which I'm trying to apply the BFS to, whether it is the smaller node or not than the current node, right? So just check this out, guys. Let me like finish this once and then we can easily discuss everything, right? So here I'll get all the double x and double y values, right? So let me just print out one double x for you, right? So what we have is we have taken a queue initially post 0 comma 0. So dxi plus dyi, great. X dot, okay, just a second. Before completing the code, let's, okay, so there's a slight mistake, guys. Here it should be while not queue dot empty, right? That means until the queue is not empty, then perform the BFS, right? So right now you can easily see that for 0 comma 0 that was pushed into the queue, I have these four nodes as the adjacent nodes, right? So these are the values of double x and double y, right? So what should be my first case when, if I want to apply a BFS to another cell? The first case should be very easy, that if double x should be greater than equal to 0, right? That means it should be inside my grid, the x-axis. Similarly, guys, y should be inside my grid. Similarly, x should be less than n, and similarly y should be less than m. Cool. What are these four conditions for? These four conditions tell us whether the element, the next cell, they are within the grid or not, right? So what are the next conditions? The next conditions are simple, that it should not be visited. For that, what we are doing is we're just checking the distance of double x double y should not be equal to -1. Simple, right? That means if the distance is not equal to minus, sorry, it should be equal to -1. So if the distance of the next cell is equal to -1, that means it is not visited till now, right? And we'll update the distance over here. And what is the next condition, guys? That it's the next cell, if I want to go to the next cell, it should be less than the current cell. So for that, what I'll do is I'll simply say a double x double y. What is a here? The value array. Then we have taken as an input, right? So a double x double y should be less than axy. Cool. By the way, how do you make this cells to be a graph? Okay, Stalin. So here what I'm trying to explain is that we are applying graph algorithms to a 2D grid problem, right? So as you can easily see, this BFS is a graph problem, right? It is a graph algorithm, sorry, right? So we are applying a graph algorithm to a 2D grid, right? So for explanation purposes, I was converting this grid to a graph for explanation purposes, right? But in my code part, I won't be actually converting the grid to a graph. I'll directly apply my BFS on the grid itself. Instead of making notes of the graph, having some edges, right? I'll simply apply the BFS on the grid itself. Why? Because I want to save space, right? Space complexity will be less if I directly apply BFS on the grid. Why dy and dx? So I've already explained this, guys. Why dy and dx? Because dy and dx will give me the four adjacent neighbors of the current cell. So instead of writing all the four neighbors one by one, what I can do is I'll simply apply a for loop, get four adjacent neighbors. So these are the four neighbors of 0 comma 0, guys, right? This part has already been explained here. Cool. So that's why I'm running this loop till force and adding dxi and dyi, right? Why? Because firstly 0 and 1 will be added to x and y respectively. Then 0 and -1 will be added to x and y respectively. Then -1 and 0 will be added, and then 1 and 0 will be added. Cool. Right. Now what I'll do is, if the next value of the next cell to which I'm going to, if it is less than the value of the current cell, then simply q dot. Okay, so then what we can see is we can simply update the distance also. Let's update the distance. So distance of x comma double xy is equal to distance xy plus 1. Cool. And what's the second part here? Let's push it into the cube. So let's push double x comma double y into the cube, because that's how BFS works, right? So after this particular function ends, after this whole while loop ends, after the either all the cells are visited or no more cells are to be visited, right? Then what we get is we get the distances for all the values, right? So let me print all these distances after it finishes. So cout distance ij, right? So we can easily see, guys, 9 has a distance 0. Then from 9 I can go to 1 with a distance of 1. Then I can go to 8 with a distance of 8, right? And from 8 I can go to 4. So the distance from 9 to 4, the shortest distance, is equal to 2, right? By 9 to 8 and 8 to 4. Cool, guys. Similarly, you can check out all the other distances, right? So what is the shortest path from 1 comma 1 to, sorry, 0 comma 0 to n minus 1 comma n minus 1, because right now it is a zero based indexing, it is equal to 5. Cool. Why do some nodes have distance equal to minus 1? Because there is no path to that particular node. From 9, if you start, you cannot go to 4, you cannot visit 4. Why? Because there is no decreasing path from 9 to 4. 9 1, and then from 1 to 4 it's increasing. 9 8 4 3, then again 4 it is increasing, right? Y, acha, okay, so you are saying y plus 1 here, right? See, what is distance of xy? Distance of xy is equal to the shortest distance from the source node, right? So from source node I am on some particular node x comma y, and I know the distance that is equal to, let's say, a. From this x comma y, I'm going to its adjacent nodes which are not yet visited. So what is the distance of these adjacent nodes to from the source node? It is equal to the distance of x comma y plus 1, right? Because they're adjacent to x comma y. Yeah. So now what? So now path gives me a, let's say, what we say, another follow up, right? Okay, print the path, print the shortest path, right? So yes, we can print this path. And how can we print this path? It's very easy. What I'll do is I'll simply start backwards, right? I'll start from 5. So guys, 5 why is there a 5? Because one of its adjacent cells may have a distance equal to 4, right? I hope you are getting this. Why is there a 5 here? Because one of its adjacent nodes have 4. That's why 4 plus 1 is 5. So from 5 I'll go to 4. Why was there a 4? Because one of its adjacent cells has 3. From 4 I'll go to 3. Then from 3 I'll go to 2, then 1, and then finally I'll come to 0. So this path, that 5 4 3 2 1, right? I'll trace back this path, reverse it. That will be my path from 0 comma 0 to n minus 1 comma n minus 1, right? So what is the length of the shortest path? It is distance n minus 1 m minus 1, right? Let me print this. What we get here is we get 5. That 5 is the length of the shortest path. Now paths has asked us to print the path, right? So let's do this, no problem. So what I'll do is I'll try and trace back, right? What does tracing back means? Right now I have a path 5. From 5 I'll try and go on all the its adjacent nodes which has a 4. From 4 I'll go try and go to all the adjacent nodes which has a 3, right? Then 2, then 1, and then 0, right? So just tell me, if you do you want me to code it out, or you can try it yourself, because I can code it out, it's not a big deal. Okay, any coupon code for the courses, right? We have some coupon codes. Let coding minutes reply to you in a while. So parts, code it, sir. Great. So let's code it out, no problem with that. So right now I'm on the last cell, which is n comma m, right? So let's say x comma y, right? So initially x comma y is equal to, x is equal to n minus 1 and y is equal to m minus 1. Right now I'm on the last cell, right? And what where I want to go is I want to go on the cell which is 0 comma 0, like I just want to trace back. Cool. So what I'll do is let's apply a while loop until mm, x is not equal to 0 and y is not equal to 0, right? Until both of them are not equal to 0, that means one way or another I have to go to 0 comma 0, right? So until they are not equal to 0, let's trace back. So right now this question has become a little advanced, right? Because I'm tracing back. Cool. So again, let me copy this part. This part will help me go to the adjacent nodes, right? So I don't have a queue over here. Let's remove this. Okay, I don't want this distance over here. Let's remove this. Okay, let me remove this printing part too. So what I'm doing here, guys, I'm starting from the last cell. So if you have not done, let me like suggest you a similar problem. It is longest increasing sequence, right? In a 2D grid, right? So that's another problem. And then we have like longest common subsequence problem in dynamic programming, in which we fill the grid and try to trace back, right? You can also try that. So it's a very similar problem to that now. So right now I'm on the last cell and I'll try to find the new x and new y's from to which I want to go to. So they should be inside the limit. Of course, that part is good. Now the next part is the distance of double x and double y which I want to go to should be equal to distance of xy minus 1. Why minus 1? Because I'm trying to trace back from 5 I want to go to 4, then 3, then 2, then 1, and then 0, right? So that will become my new x. So and that will become my new y. Cool. And finally, whenever I find one node related to this, I'll simply break this for loop so that I don't go to any other node, right? So I'll simply break it out. And finally, guys, let's print this path. Let's print this path, right? This will be a reverse path. And if I want to like find the original path from 0 comma 0, I can simply store these values and reverse the original path, right? So let's print this and check it out. Let me remove this 5 also. Yeah, we can also do it that way, but I want to save space, right? I don't want another space of parent array. So that's why we can try this. So yeah, so earlier I was on 3 comma 2, which is the last cell. Then I went to 3 comma 1. What is 3 comma 1? It is this cell, right? That means 0 to 1. Then from 3 comma 1 I go to, okay, so here it should not be and, it should be or, right? Cool. So here I've got two more options. That is, see why is the difference between and or? I want to reach 0 comma 0, right? From 0 comma 0 I don't want to go anywhere else, right? So that's why I'm starting from 3 comma 2, going to 3 comma 1, then 2 comma 1, then 2 comma 0, then 1 comma 0, right? That means any one of these nodes can be 0, right? Because it's a 0 based index. If it would have been a 1 based indexing, then and would have worked here, right? That means I just have to choose my terminal position uh, wisely, right? Depends completely on like 0 based indexing or 1 based indexing. So this is a path, guys. And finally we have the last cell, which is 0 comma 0. Or what I can do is, guys, another, I can simply say while one, let's print x and y. So this while loop will go on forever, and let me have a breaking condition. If x is equal to 0 and y is equal to 0, let's break it out. Cool. So that's become more easy for us. That whenever we reach 0 comma 0, first print it, then break it, right? So I don't have to print 0 comma 0 again. So any other doubts in this, guys? I hope not. Cool. So do you want me to go to the next problem? Okay, let's move on to the next problem, guys. So the next problem that I have selected for you is that you have been given a grid. Okay, so moving on to the next problem. If there are doubts, let me know. I'm continuously looking at the live chat section. So given a grid of size n cross m, same, all cells have values written on them, same. You only have to move to a cell which has a lesser value than the current cell with a cost 0. Now guys, we have got a cost over here. We have got a new term called cost, right? So if I move from a cell to another cell which has a lower value, then the cost is 0. Means with a 0 cost, I can traverse that edge. I can go to that cell. But cost of moving to a higher cell is equal to absolute difference between the values of the cells, right? Uh, Kulbir, I already told you, if you are not familiar with the coding stuff, then you can check out our courses, right? It's not a one day's job that right now if I try to explain you for loops and while loops and then make you understand BFS, it will take a lot of time, like probably 2 3 hours or more than that, right? So that's why uh, there's this a little advice. Try and grasp the logic over here, build uh, and try and like learn the coding part through courses which are very pocket friendly courses, like very pocket friendly courses. You can try them, and after that, if you like, if you're really interested, come back to this particular video, watch it again, and then understand the code, right? I cannot make you understand the code right now if you don't know the basics of this, right? So you need to understand, see, it's not always that you want to understand a language to understand graph algorithms. You can understand graph algorithms in any way, right? So what does a language do? It tries to implement that algorithm so that the machine understands the code, right? So there are lots of languages: Java, C++, Python, Ruby, C hash. All of those languages apply these algorithms, right? So it's not necessarily to learn a code to understand any algorithm. You can understand the algorithm by reading a research paper on that, right? By uh, reading a research paper, watching some videos on there, right? But to code it out, you need to understand a language. That can be any language: Python, C++. So this is a C++ language, right? Cool. So Akash has already told us the answer here. So what it is, the cost of moving to a higher cell is equal to the absolute difference between the values of the cells. So find the minimum cost path between 1 comma 1 to n comma m, right? So as we can see guys, now this is slightly above version of the BFS. So when we are applying BFS, a normal BFS, it was based on unweighted graphs, right? But this problem will be converted to a weighted graph. Let me explain you how. Let's take a grid, guys, a small grid for an example. So the guys, these are only the types of the problems that are being asked in FANG companies, right? A simple problem, but what they want is they want a really clean, clean code, right? A clean code. That means you do not get stuck in coding part. You write a very clean code. You are able to explain to them very clearly so that they know that you know the basics of this algorithm, right? The problems are fairly easy. They just want you to be clean at whatever you do, right? So here let's have a 4x4 grid, right? And let me write some values here. So doesn't mean that we always need an decreasing path now, right? So I've just written some random values over here, and cool. So now guys, what we can do is we have to make a graph, right? And here all the nodes will be connected with their adjacent nodes. Why? Because now I've given a cost. So let me make this graph first, and then we'll add edges with weights. So this becomes a version of the Dijkstra's algorithm. We'll see that, right? So now there is this edge from 1 to 2, and what so now we are moving from 1 to 2. What is 1 to 2? It is a higher number than 2, higher number than 1, right? So what is the cost of this edge? Is equal to absolute difference between 1 and 2, right? That is 1. Cool. From 2 I can go to 1 with a cost 0. Similarly, this has a cost 0, but this has a cost 1. So this has a cost uh, 3, that is 4 minus 1, and this has a cost 0, right? So again 1, 0, 3, 0. So this is 2, 0, right? So one of the two edges have to be 0, because they are, one element will be less than the another element. Cool, guys. So in this way we can make this graph from 2 to 5 with a weight of 3 and 5 to 2 with a weight 0. So here now you can see I have a graph with some set of edges, and I want to find out the shortest path from 1 to 7, right? So what is the specialty of this graph? That it is a weighted graph, weighted directed graph, right? So what I'll do here is I'll simply apply a, what do we say, Dijkstra's algorithm, right? So instead of BFS, instead of Q, we can simply keep a priority queue, right? Which will always have the shortest path on the top of it, and we'll always explore the shortest path until we reach the final node, right? Just a follow-up question for the previous problem. In the previous problem, we can just go to another cell which has a lower value, but now we can go to a cell which has a higher value with a cost equal to absolute difference between both the cells. Cool, guys. So I hope this is very clear. So instead of this queue, what we have to do is we have to give a priority queue and have an Dijkstra's type of explanation or an implementation, right? So I'm just leaving it to you, because now it's a little medium hard problem, and you all can code it, right? So for same elements, we can go with a cost 0. Cool, Parth? Great. Now let's move on to the last problem that I have kept for you. Again, it's a very nice problem, and we will code this out. So given a binary grid of size n cross m, cells with value 0 are blocked. Of course, we have a binary grid, ones and zeros will only be there. You need to start from a cell on the first row. Find the shortest path to any cell on the last row. Getting this? From the first row, you can start through any cell. Of course, the cell should not be blocked. That means I can go on 1. So I can only travel on 1 in the binary grid, and I want to find out the shortest path to any cell of the last row, right? I have to start from the first row. I can go in any direction and find the shortest path to any cell on the last row, right? Just try and understand this problem. Let me frame you an example. Okay, so I need to have more rows. So in this question, if we ask to print the shortest path, then how to do it? Okay, so you were asking the previous problem, right, Sheldon? Great. So see, if in the previous problem, if I want to print the shortest path, then again it's a very easy thing to do, right? I simply need to trace back. So earlier in the BFS, we were having a path with 5, 4, 3, 2, 1. That means the difference between the distances to which I need to go is 1, right? But right now, the difference is not 1. It is equal to the cost between those vertices. right? So it will be same, it will exactly be same, right? Same as this particular algorithm, just instead of -1, what I'll have here is I'll have some cost value, that if that distance is equal to current distance minus cost, then go to that node because that is the shortest, right? So I hope this is being clear. Instead of -1, we will have, okay, this only, sorry, right? If you, okay, let me explain this problem and then we can move on, right, to printing the shortest paths. Apply BFS DFS n times. No, that's not it. So here you learn a new topic, guys. It's very related to breadth first search only, but a new topic for you, or some of you, not all of you. If so, let me write some. Right. So what are the starting destinations here? The starting destinations are 1, 1, and 1. What are the ending destinations here? Either these three ones, right? Or if I want to make some more ending destinations, let me write some random ones here, right? So we can end on these ones. I want to find the shortest distance from any of these ones to any of these ones. So any of the ones in the first row and any of these ones in the last row. Cool. So I hope the problem statement is very clear, right? So let's try and find some paths. So from this one I can go to this one and then I cannot go anywhere. And this way I can go to this one, then this one, this, or directly here, right? So I think this can be one of the shortest paths. But let me change this a little. So let's say we don't have ones over here. We have zeros. And right. Cool. So now you can easily see the shortest path is from the right hand side. Right. So that's not the main point, guys. The main point is to solve this particular problem in really good time. Right. So what are your approaches for this problem? Let me know in the chat section. Okay, so right now not getting many approaches here. So guys, this is a problem of a very BFS from starting node traversal end, right? So this is a problem of a very not known topic, but a very easy topic. It's called multi-source BFS, right? So earlier what we used to do was in the queue we used to push only one source, that is the starting node. But here we have different starting nodes, right? So here we have many starting nodes. So for this example, we have three starting nodes. So what we'll do is we will simply apply a multi-source BFS. We will push all the sources of the starting cells into my breadth first search queue, right? So it's not about BFS n times. We don't have to apply BFS from every node again and again and finally find the shortest path. We will, because guys, that BFS can take O of nm time. See, that can take O of nm time, right? And how many times we have to apply that BFS? I have to apply that BFS m times, right? Why? Because there are m columns in the first row. So if I do that, if I try to apply a BFS again and again, so it will, that complexity will become nm into m, that is nm square, right? But nm square is not a good solution for this particular problem. What is a good solution, guys? So right now we have come down a little advanced part of our workshop, right? We have seen easy, we have seen intermediate, we have seen hard. Now we are on some advanced part of this workshop, right? So from the first row, guys, we have three different source cells, right? So what I'll do is I'll apply a multi-source BFS. So instead of pushing only one starting cell into my queue, I will push three cells into my queue in my BFS. Cool. Let me explain you how. So let's understand the working of this, and let me copy this. Right. So I both of these are visible, right? And I just have to erase this again and again. Just give me a minute. Let me erase all of this. Okay, I do not know if there's a shortcut for this, but I'm doing a brute force removal here. Right. So guys, the down matrix will become the distance matrix that I want. Right, the distance of the BFS, which will give me the shortest path, of course. Right. So what I'll do is, as I said, I'll apply a multi-source BFS. Multi-source BFS. So in a single source BFS, we used to push one element into the queue here, push one into the queue, mark is distance 0, right? But now what I'll do is I'll push multiple sources in my BFS and mark it distance to be 0. So what are the sources, guys? 0, 0, and 0. So distance of these cells are 0 to any of the starting cells of the first row, right? So these three nodes are the sources. We can easily see that these three nodes are the sources in the first cell, right? Now what I'll do is I'll simply apply a normal BFS, right? That go to all the adjacent cells if they are not visited, and the distance of those adjacent cells will be equal to distance of the current cell plus 1. Simple, right? As easy as that. So let's start from the first 0, right? So here I'll get, okay, the distance is equal to 1 to the down of 1. I will not be able to go on the right of it, not on the left of it, and I'll push this 1 into the queue, right? Now for this, but now let's come on to this particular 0. So again, guys, 1 over here, 1 over here, and then we will have 2 over here. So guys, from this one I cannot go anywhere in the BFS because uh, the upper node is already visited. The left, I'm talking about this one, right? This one, the one on 2 comma 2. So the upper node is 1 itself, which is visited. Left is 0, right is 0, down is 0. So I cannot go to any of the other ones, right? Now on from this right hand side, I can go to this 2 over here, and this is also equal to 2, right? So similarly, guys, all the 0 cells are visited first, then all the 1 cells are visited first. Once means the distance of 1. Then all the cells with the distance of 2 are visited, right? So this is 2, this is 2, this is 2, and there are no more 2s. Now we will get 3s, right? So for these 2s, guys, of course, for this particular 2, I cannot go anywhere. So it's a dead end. For this particular 2 also, I cannot go anywhere, again a dead end, but this 2 can lead to this 3, right? The distance is 3, then 4, then it will be 5, then 6, then 7, and then we'll have 2 8s over here in the BFS, then we'll have a 9 and a 9 here, right? So the first cell which will be visited in the last row will have a distance of 9, has a distance of 9 in the BFS, right? So now you can easily see that what does a multi-source BFS means, right? That means all the multiple sources, the initial sources, are at a distance of 0, right? And in one by one, I will visit the cells with a distance of 1 from all the sources. Then I'll visit the cell with a distance of 2 from all the sources, right? So that's how a multiple source BFS works, right? So let's code it out, guys. A very easy approach here. And yeah, let's take input. So let's have an input, guys. Let's take a very small input right now. So 1 0 1 1 0 0, and let's say 0 0. Okay, let me 1 here and let me 1 here. Cool. So wait, give me a second. Floyd Warshall will not work, as I already told you, and pushing all associate at the same time. Amazing. Acha. It's a well-known algorithm, multi-source BFS. So in my graph algorithm course, I've discussed some great tricks like these only, like multi-source BFS, zero one BFS. There are other topics which are discussed in our course, and a very pocket-friendly course, guys. You won't uh, regret it buying it, because there are lots of assignments, like approximately 100 problems that you can code there from the topic you just learned. We have flows, we have strongly connected components. So I have actually covered most of the topic that are required to, like, that are essential for competitive programming in graph theory, right? So you can check that out. So let's code it out, guys. Right, so let's take nnm, let's input nnm. Right now I won't go to the basics of the code now. Cool. Let's move is a little pace, because pace is what's needed in competitive programming, right? So let's input it ij. So right now I have this 2D matrix as an input, which has zeros and ones. I can take boolean here, but doesn't matter. Let's take the distance array now. So distance minus one, size of distance. Right. So guys, what will be the complexity of the multiple source BFS? According to your understanding, let me know. Tell me the complexity of this multi-source BFS that we have already discussed, according to your understanding. So let's memset this and let's take a queue, right? So what will this queue be type? So this queue will be equal to pair intent and queue. O and M. Great, children. Correct. Right. So initially the distance is 0. So what I have to do is I have to go in the first row. Let's go in the first row, right? So j equals to 0, j less than m, j plus plus. So I'm going to all the cells in the first row, and in this queue I'll push 0 comma. Okay, so not right now. So if aij, that means if there is 1, then I'll simply push 0 comma j into my queue, right? So I'll push the particular cell of the first row into my queue, right? Now what I need to do is I need to perform a, okay, so when I push this queue, I also need to mark the distances to be equal to 0, right? That's how BFS works. Mark the distances 0, mark the source node 0, and move on. So distance of 0j is 0. Now let's copy this normal BFS part. So I've copied this. So we have this dx dy, of course, and then we have x and y. Great. So we need these four conditions, guys, so that the item is within the limit. We need this condition so that it is not equal to 0, and we need this last condition, which is it should be equal to 1, so that I don't go on any blocked cells, right? And finally the rest all part is same. The distance xy is equal to 1, right? So guys, you might be wondering that if there are two paths to some node from two different sources, that from first source also there is a path, from second source also there is a path. So we know the speciality of BFS is that it finds the shortest path first. So whatever will be the shortest path to the current node from any of the source, that path will be visited first in the BFS. If that will be visited first, its distance value will be updated to the shortest path, and the next time its distance value will not be updated. Why? Because it has already been updated. It is not equal to -1, right? So always the shortest path for any cell from all the particular sources will be covered. So guys, here I want you to try uh, one problem from lead code if you want to understand this multi-source BFS topic, that is 0 1 matrix on lead code. Just go and like after the workshop ends, just go and like try and code it out, 0 1 matrix in on the lead code, and try applying this particular uh, multi-source BFS example that I'm showing you, right? So in that problem, what we have to do is we have to find out the shortest path for all the ones in the matrix, right? So we have to find out the distance, the nearest, the closest zero from all the ones. So for all the ones, we have to find out where is the short. Okay, so what's the problem? Aij. Where is Aij? Okay, okay, it should be 0j, not Aij. My bad. Cool. So guys, we can easily see that all the zeros will have a distance of 0, and all the ones which are not connected will also have a distance of -1, right? Now, the distance of the source nodes are 0 on the first row. You can easily see this. Now, the distance of this node, that means cell 1 comma 0 is 1. Then we move to right of it, which is a distance of 2, and then we move down of it, which is a distance 3. So after this BFS ends, what is the shortest distance of any node? Let me write it, or let's say answer. Right. So initially, let me give it int max, right? And what I'll do is I'll simply say answer is equal to minimum of answer comma distance I, not ij. Sorry, my bad. So if I want to find this answer, what I will do is I'll simply iterate on the last row of the distance array, right? So let me iterate on the last row of the distance array. Minimum of answer comma last row, right? So it will be m, and we'll write 0 comma n minus 1 comma I. Cool. And of course, guys, this will only work if distance n minus 1 I is not equal to -1. Otherwise, -1 will come as the minimum, right? So let me save it, move above, and let me print this out. Cool. So we can easily see that the shortest path is 3. Let's make another shortest path, guys. I've just added 2 more ones there. And cool. Now the shortest path is 0. How? Because we started 0 here, 1 here, and 2 here. Straight. Cool. So this was about multi-source BFS. So again, guys, it is a graph problem. It is a graph. It is a 2D grid problem which is being solved using a graph algorithm, which is a extended version of a BFS, a multi-source BFS, right? So I hope you enjoyed this workshop. I hope it is enough knowledgeable for you all. Like you understood all of this, and you gained something new in this workshop. So we'll like keep on having new workshops, right? And in the comment section, you can let me know on which topic you want another workshop. Cool. So we can have some similar workshop with some easy, medium, advanced problems for a particular topic, and then you can practice all those problems. And of course, if you want to master all these algorithm at one place, then you can simply check out my courses on codingminutes.com. Right? Thank you, guys. See you in the next part.